A shop sign weighing 215 Newton hangs from the end of the uniform 155 Newton beam. Find the tension in the supporting wire at angle 35 degrees and the horizontal and vertical forces exerted by the hinge on the beam at the wall. So first of all, to solve this problem, we have to show all forces acting on our object, which is a beam. This is a beam. We will have tension along the wire applied at this particular point. We will have the weight of the shop sign, which is 215 newtons, and we will have the weight of the beam. The weight of the beam will be applied in the middle of the beam because we assume that the beam is uniform. So we will have the weight of the beam, and this is 155 Newton. So we have three forces acting at this moment of time on our picture. But we have to add another forces. We have to include here horizontal and vertical forces acting on the beam in the pivoting point. I have no idea about the directions of these forces, so let's assume that we have vertical, F vertical, let's say up, and horizontal, let's say to the right. If we will have wrong suggestion doing that, we will come up with a minus at the magnitude for these particular components, and we'll be able to invert them. First, we will find the tension in the wire. To do that, we have to put axis of rotation perpendicular to the beam at the point, pivoting point of the beam. In this case, the forces, vertical and horizontal, acting on the beam will not be able to rotate because they act on the axis of rotation, so they will not exert any torques at all. And net torque, which is supposed to be zero in case of the equilibrium, will be only due to the tension force, due to the weight of the beam, and due to the weight of the shop sign. So we will have zero equal torque due to the tension will be positive because it strives to rotate counterclockwise. So by magnitude it would be tension force times force arm, which you can find if you will draw a perpendicular line. So this is a right angle towards the line over which tension acts. Having in mind that this is 35 degrees, we can look at this triangle and find from this triangle the force arm length of perpendicular line to the line over which tension force acts. To do this, we have to calculate this leg in our triangle, and this leg would be hypotenuse, which is 1.35 meters, times sine of the angle 35 degrees. Then we have to add the torque due to the weight of the beam. This force will rotate clockwise, so the torque would be negative, and you will have the weight of the beam, 155 Newton, times half of the length of the beam. Half of the length of the beam would be 1.7 meters divided by 2. And we have to add torque due to the shop sign. Shop sign will, weight of the shop sign will rotate our beam clockwise, so the torque will be negative, and the magnitude will be equal the force itself, 215 meters, times the length of the perpendicular line, which you will draw from the axis of rotation. So this is 90 degrees angle as well. So you will have just the length of the beam, 1.7 meters. If you will solve this equation for the t, you will come up with the particular value, 642.2 Newton. We did find the tension. Now our goal is to find vertical and horizontal components. To do that, we will use second important equation, that the net force has to be equal to 0. So we have the following forces. We will have three forces: T, weight of the beam, weight of the shop sign, and we have two components, vertical and horizontal, acting on the beam. Net force equal to 0 means that F net x component would be 0, total F net y component will be 0. You see that you have here only one horizontal component due to the tension. So you can claim that for the horizontal axis, which I will put along the beam, I will have that F horizontal positive, this one, minus T times cosine 35 degrees has to be equal to 0. From here we have that F horizontal would be T times cosine 35 degrees. T we did find, so it's 642.2 Newton times cosine 35 degrees. And if you will do these calculations, you will have that horizontal component would be equal to some particular value. I will not calculate that. For the y component, you will have F vertical plus T times sine 35 degrees minus two forces, weight of the beam and minus weight of the commercial sine, equal to 0. Solving this equation for the Fy, you will have 642.2 Newton times sine 35 degrees with the sign minus plus 155 Newton plus 215 Newton. And if you will do calculations, you will have small number 1.65 Newton. Because it's positive, we suggested direction of the force, vertical component, correctly. It's indeed directed upward. If you will come up with the negative value, it simply means that you, in this case, have force directed downward, not upward. We solved the problem.